All right, welcome to a tutorial on a stocks app. What I've got here is an app where you can type in a symbol, like AAPL for Apple, pick a start date and an end date, and based on how far apart those are, it picks a resolution, like a 10-minute chart or a 1-hour chart, and then charts the stock, and then you can see the different candlesticks. And this is a fairly large project, so it's got a bunch of different sections for the tutorial. I'll go over the README in a second here, but just to demo the app. Oh, sorry, my keyboard is not open. Type in Apple, pick a start date, pick an end date, and then we hit search, get a little loading chart, and then we get Apple from the 12th to the date that I picked. Now it looks a little weird with so few days. Maybe we should pick a couple more days here. Pick the start date a little bit further back, maybe a little more. Search like that. And then when you rotate the screen, which is a bit awkward with the emulator, actually looks pretty goofy, honestly, and then you have to press the button that was there for a second. Sorry, one sec. Press that guy, and then the app bar disappears, and then you can see it much clearer here when it's rotated like that. Okay, so let's get into the README for the different sections here. First up, there are some prerequisites. There's a couple concepts I already have complete tutorials on that we're not going to go into too much detail. I'm going to go over them a little bit. But knowing how freezed is used to generate two-string equality copy within hash code, freeze is a fantastic plugin to generate just a whole bunch of boilerplate for us, and I've used that heavily in this project. As you can see, there's quite a few different classes that has freezed parts to it. The other one is knowing how JSON serializable is used to generate to and from JSON. Of course, this comes from an API and it's real data, so we need JSON serializing and deserializing. These are these .g files. And then knowing how block and qubit work in general. So I'm going to go over those things, but not in great detail. Okay, so first up, we're going to go over a background of what it means to have a candle on a stocks chart, define the different things that are in the model: open, close, high, low, bullish, and bearish, just to get a general understanding of what we're even plotting here if you don't really look at stocks much. And then a brief intro to Syncfusion Flutter charts, which is the plugin that I have used to plot this here. A little bit more background, I'm using an API called Finnhub. Both Finnhub and Syncfusion, if you wanted to make a real production scale app with them, you would need to pay them. Neither of these things are free to use. They're free to experiment with, obviously, but not free to completely use. So just a disclaimer there. If you wanted, a million people to use your app, you would need to pay them a fair amount of money. So yeah, I'm going to go over the Finnhub API and just show you their website, and it's got an awful lot of different things that are very easy to use, and if you just give them your email, you get a token you can play around with and see example requests. So I'll show you a sample for the endpoint that I'm using here, which is v1/stock/candle. Then we're going to go over the modeling of that. So once we've seen the JSON, we know what we got to put into our Dart classes. So then making the models for the payload that we get, and also I've modeled out the request to get them. So these are like the headers in the request, or sorry, the query parameters. We're going to generate the .freeze and .g files so that half of this stuff is actually generated code, so I don't have to write nearly as much. And then I'm going to map our API payload, which is actually in a bit strange of a format, into a nicer model to actually plot with. So the model that I actually plot is called candle, which represents one candle here. Then we're going to show the API in Dart itself. So the API, this one you need an API key to use. And API keys are not the sort of thing that you want to advertise or check into version control. So I have used a .env file, which is green here because it is get ignored, which houses my API key. So I'll show you how to use Flutter config to do that. It's really easy. And then we're going to use that Finnhub API with just one endpoint to get a stock quote. So this is a single quote. It's not live updating. It doesn't have WebSockets. You can't scroll to lazily load further back dates. The tutorial is already pretty large without doing that sort of stuff, but I'm not going to recreate Weeble from scratch for a tutorial, obviously. So I'm going to look at our app state, and for that I'm using block. So we're defining the app state. What variables do I need to keep track of to know that it's loading and succeeded and stuff like that? I'm going to use block and actually the qubit class to call the API that we've written up above, and then put those candles that we get into our app state. Then I'll show you the search form, which is the previous screen, which has these fields here. And this is a proper form with validation, so if you hit search and it's required and you can't put the start date and the end date such that the duration is negative, stuff like that. and then show you how I use the chart. And the chart is actually amazingly easy to use if you have an app that is going to heavily use charting. This Syncfusion plugin seems awesome for that. I have never used it professionally and actually paid them, so I don't know exactly how much it costs, but it looks really good. It's very easy to use. Okay, so let's get back into the background here for section 1. So I've got a bunch of web pages open. So here we are with what a candle actually is and why it's green or red. So a green candle, you can imagine this actually houses a certain period of time. Let's say this is an hour of time. Well, it opened, meaning the stock went and it hit this corner, and then low, it went down to here at some point, and then up to the high at some point, but eventually it got back to this level, which is the close level. And then the bearish candle, which is red, is very similar, except overall it went down. So it hit this corner, did something crazy, and then eventually hit close. So you can see that it went from this corner to this corner, so on average, it went down over this time period. And the candle can represent pretty much any duration of time that you want. Normally it's in times of like an hour or a day or 10 minutes, 30 minutes, stuff like that. You can even go down to the 1 minute if you really want. Okay, so let's look at the API. So this is Finnhub, their website, and this is the endpoint that I'm going to be using right here. So over here, scrolling down, or not that far, it's right here, so candles. So what candles is going to get us when we hit this is a sample response here. It has close, high, low, open, a status code in here, which is a bit weird. Normally status codes, you just use the HTTP status code, but it's here. And then the timestamp, and this is Unix seconds from epoch, not milliseconds. And then the volume, and volume is not really used in this app. We can just kind of ignore it. So yeah, they're just represented by these one letter for all of the different keys. And one thing that's a little bit weird about this is that this is not one candle here. One candle would be the first element in every single array put into one thing with this timestamp and this open and this low, and eventually that would plot you a candle. So that's why I have this little transformation layer where we're going to pull out the first one and then the second one to map them into an object that's a little easier to plot, that just houses everything that one candle has. So here's the supported resolutions: 1 minute, 5 minute, 15 minutes, 30 minutes, 60, day, week, and month. Oh, I think I forgot week. That's okay. I'm not going to bother adding it right now. And yeah, let's look at what a actual response would be. So when I click this link and I'm logged in and I have my API token, it gives me this here. So this is pretty hard to read alone, so I just copy and paste that and put it into a JSON formatter and then hit process, and we come down here and we can see that we get our data here just like they said in the documentation. And this is for Apple at I don't know what day, probably a long time ago, because Apple's quite a bit above that. So if we can imagine what that would actually look like on a chart, I have Weeble open here as well. So this is our goal. This is Apple. This is what it's supposed to look like if we did a chart of, about 20 days. So yeah, again, my chart can't scroll and it can't lazily load data that's further in the past, but just kind of a simple one quote, one graph sort of thing. The other thing is the Syncfusion Flutter charts. Going to go over that plugin, their pub.dev here. So they just have an awful bunch of charts in here. It's kind of insane how many different charts they have. The plugin is maintained really well. They have a lot of different versions up. They're already on like their 18th major version. But basically, here's a whole bunch of different charts that you can make, and they are really quite easy to implement. And a lot of them have really nice animations and easy API to use and change the colors and whatnot. There are some on here that are actually not even listed that are on their main website, and I'm using one for the stocks that's not even here, so we'll see that later. And then you can also control the axes with these classes, so you can make them into a category or 1, 2, 3, 4, 5, or make them into dates, or even put them in a logarithmic, and all of that is just done instantly for you. But keep in mind, this plugin is paid if you want to use it professionally for a real app. So just keep that in mind. So next up, modeling. We've seen what the Finnhub API returns us, which is lists under letters like C, L, and whatever. So let's get into modeling. So candles payload is the class that I have defined to house that response. So with that, I've used both freezed and JSON serializable to generate two other files that are kind of come with this. One of them is .freezed and one of them is .g. So the .freezed has equality toString, hash code, and copy with, and the .g has the to and from JSON. So all I gotta do is mark this as freezed, give it a private constructor, put in the annotation here, and then give it all a whole bunch of default values, because I feel like it's a little cleaner if these come back with empty lists if there's no data, instead of it basically just crashing. So yeah, I've named my variables a little nicer with the full name here, but again, the JSON key that comes back are just the single letters. I also have a method here, toCandles. So candle is my class which this is going to map to. So let's open up that next. So what we need to do is I just do an assert to make sure that everything's the same length. If they weren't the same length, this wouldn't really work very well, because I'm just using the close.length to just iterate through every single one, and just pluck off the index there and take that timestamp times 1,000, right? Because Unix timestamp, they've said this is the seconds since epoch, but datetime has a constructor for milliseconds since epoch. So we got to times that by 1,000 to put that into a datetime, and then pull off the volume as well. So one candle's payload makes us a whole bunch of different candles. All right, so let's look at candle. Candle's a very small class thanks to freezed, and it just has the close, high, low, open, timestamp, and volume. Okay, we can also model out the request that we're making. So on their docs, we saw that they require a resolution with the time period, the to and the from, and these are Unix seconds. So this is the request that we're going to send them, along with the symbol with the 4 or 5 letters or however many letters for the stock, to actually get our data. And I like to put this into a model as well. You could hard code this resolution, whatever, in your API, but having just headers, my query parameters are a get candles request to JSON is very, very simple and not very error prone. So one thing that I learned about freezed here is that I only want to JSON, because this is for my query parameters, but it didn't make me one unless I put from JSON. So this is unused, but it seems to have to be there for my generated file to work properly. So let's just look inside one of those generated files just to get a handle on that. So again, the freezed class has all of the, has a copy with, sorry, that's not copy with. So here's where all of the actual variables lives. It makes a final instance of each of those that I've defined, and then it puts the JSON key on there for me. Makes a toString with all of that for debugging. It does an equality with a deep collection equality on everything, and it has a hash code, and then it just generates me all of that stuff without having to do anything. Really, really nice. Then we go over to the candles.g. This has all of the nitty-gritty JSON stuff, so we're going to pull off the close list as a list of dynamic, and if it's not null, we're going to map those to double, and if it is null, then we're going to use an empty array. And again, all of this is generated code. I don't need to write any of this with those two plugins. Okay. So now that we've done our modeling, here's the command to generate those files if you ever need that. And we've mapped the API payload to a nicer model. Let's look at the API in Dart. So the first thing is that, again, this needs an API key. So API keys are secrets to some degree. If somebody wants your API key badly enough, they can probably get it by decompiling your app, but even then, you don't really want to show off what your API keys are. So it's good to put those into a file that is like get ignored, and that is .env. And I'm using a plugin called Flutter config to pull that out into my app. So that's in main. So in here, the project has a .env file which is get ignored, and it has my API key. All I got to do to get it is go await flutter config.load env variables, and then I get my API key, and then I build my API class based on that API key. So let's look at my API class. So it's right over here. So for my API class, its HTTP client is using the plugin called Dio, which has our methods like get and post and stuff. This one only uses get, but Dio has a couple things that are extremely convenient. One of them is base URL. So I know that every single request this app is going to make is going to be to Finnhub, or at least that this class is going to make. So everything, there's no point in writing this out a million times. For my get request, I can just go /v1/ the endpoint I actually want to use. I can also do this thing called adding an interceptor. So on every single request, we need to add our token. And they allow you to put this in the auth section of the headers, and they also allow you to put it in the query parameters. I've decided to just put it in the query parameters. So on every single request, automatically, I don't need to remember down here, it's going to add the key token with the API key, and that is passed into this static method, which just gives me a default DO here. Then you just got to remember to call handler.next, or else the other things are just going to break. So yeah, this is a method that sets up DO for me, and then it is just passed into itself basically. But it's good to leave these things passed into your class so that if you're doing any testing, you can mock those classes and pass them in for dependency injection. Okay, so now that we got our HTTP client set up, it's got our base URL, so that's what it's going to hit, and every single request is going to add our token. We can look at get candles. So get candles returns us a future list of candle, and it needs the request. So this has got the symbol and the dates. It's asynchronous, of course, because it's the internet, and it's all inside of a try catch here. So I like to rethrow exceptions with just a message so that I can format that message for my users here, and then I only never need to catch one thing because this is a catch-all. So we're using do.get, and get takes in a generic type, so we can pass in this map of string dynamic. That's what I know the request is going to come back with, and then we hit that endpoint v1/stock/candle, and the query parameters is going to be that request.toJSON. And even though we have query parameters there, this interceptor is also going to add our token. So then we're going to get a response.data back, and data is a map because we've set it is up here. And we're just making sure it's not null, because if it's null for whatever reason, then we know that's an exception. We're supposed to get data back. So I just make that candles payload.fromJSON, right? So this is the layer where it's going to have the data like this, where they're all split up by close and high and whatever, and then map that into a bunch of candles. So we're going to get some number of candles back with that toCandles method, and that's what's returned. And then if we catch anything, just debug print it for ourselves to know what's happening, and then throw this error, an unknown error occurred. If I were to take this tutorial further, I would definitely want to check the status code of what happened or whether it timed out and give my user a better message, but I have not done that. Okie doke, so that was our API in Dart. So now we got our API, it's got our API key. We can call Finnhub and get a nice Dart class out of there. Let's set up our app state. So the next thing that we're going to do is look at my state folder with the app state and our block. So the app state is a very small class thanks to freezed again, and it has just a list of candles. That's the candles for the current request, the most recent one I've got. I didn't set this app up such that you can save the data from multiple stocks, so it's just going to overwrite the candles with whatever you get next. I thought that was sufficient for this tutorial. Obviously, if you'd want some sort of caching, you don't want to request the stuff over and over again if you already have it. Next up, we have the current symbol. This is the symbol that these candles are associated with. We have a flag for loading, whether or not there's an error, and the message that goes along with that, and then a recent query, such that I can populate this form with the most recent query so that if you go searching backwards and stuff, you don't lose what you've typed in so far. So then the initial state has no candles, no symbol, and everything's not loading and errored out. And again, we have a freeze class, which has the copy width for us, which is very nice. Okay, so here's my block, which is the app state qubit. I've just wrapped this this qubit around the entire material app, so this is effectively the state of my entire application. And it's just using qubit because there's only one thing that this block can ever do, which is load candles. So I didn't really feel the need to define a whole bunch of event classes because there isn't a whole bunch. There's only one thing it can do. So this block needs our API, and then it needs to call super to pass that initial state into qubit. So here's the method of what it can do. This is the only method in the class, which is load candles. So when we load candles, we either get a list of candles back or we get null, depending on whether it worked or not, and it's always going to be asynchronous. So here's the three things that the user picks, the symbol and the two dates. And the very first thing that we do is admit that this is loading. So we do go state.copyWith is loading true and has error false. We clear that error if there was an error before. So here's a bit of logic, and of course block for business logic. This is a great place to put logic. So what we're going to do is find the first resolution that results in less than 100 candles. So if you were to plot several years worth of data and used a resolution of 1 minute, you're going to have hundreds of thousands of candles, and it's just going to either crash your app with the running out of memory, or it's just never going to plot because it's going to be so slow. So on most apps like Webull, you can pick your resolution and it's going to zoom automatically. Again, this tutorial doesn't have that sort of thing yet. So this just finds a resolution that is going to result in something pretty decent to look at. So if we go further back, like a couple years, it's probably going to give us the monthly chart. And we can see that if you bought Apple in 2006, you would be quite happy today. Yeah. So to do that, I'm getting the milliseconds of the total duration that the user has selected, right? So this is the like the end date minus the start date in milliseconds. And then I get the number of candles by the time there and get the resolution, the duration in milliseconds. So this would be a good time to jump into how I've defined resolution, which I have used an enum for. So again, I forgot week in here, but let's just forget about that for now. So this is just an enum. But you can make an enum behave a bit like a class with extensions. And I think this is kind of a clean way to add some extra ability onto enums where you know there's not going to be any new values added later, so it's pretty solid to use an enum. But you want them to be a bit smarter and have some stuff along with them. You could also make a utility class, but I really like extensions for this sort of thing. So in the API, right, we need to tell them what our resolution is, and that doesn't take the string of resolution.1 minute. They expect a string of 1. So this is a helper method which converts our enum to the value that the API likes. Down here we have one that's a human readable label, so 1 minute, 5 minutes. So this is just a nicer string for the app bar. And then here this is the duration. So a resolution of 1 minute has a duration of 1 minute, and so on and so forth. The only one that's a little bit weird is month. Months have different amount of days, and there is no duration for month. So this one isn't perfect, but it's a good rule of thumb for just getting a resolution that works for the number of candles that we're actually going to need. And there's also this static helper method here. So when I go to JSON in my query and pass it a resolution, it returns the API key. So it maps that resolution to just the API key, which is again what the API actually expects there. So this is the number of resulting candles. We got the time divided by the resolution, and we just return the first one that gives us less than 100. I've chosen this number very arbitrarily, just based on experimentally what fits on the screen nicely. And then if none of them result in that, we just give the largest one, which is the monthly. So if you go back until 1990, it's going to be the monthly. There might be more than 100 candles, and that's fine. Okay, so now that we've got our resolution, we can start using our API. So we're going to make our get candles request. This is again the class that has a to and from JSON that the API is going to use. So we pass in the resolution, start date, end date, end date, start date, and the symbol. And then we emit that we are have made a query. So even if it fails, the user can go back and see their query. So then we just call our API and get our candles. So the get candles method on our API again takes in that get candles request, and then it returns us a list of candles in a future. So we got to await that. And then we emit a whole bunch of stuff. So we're going to emit that we're no longer loading. We're going to emit with the candles that we got. We're going to emit the current symbol as the one that the user has selected. I actually probably could have put that here as well, or instead. I don't think it matters too deeply though. And then an error message. So if you pick really weird dates like 1900, well, there's no stock market if you go far enough back, and it's not going to return you any data. So we're going to consider that an error. So if there's no candles at all, we're going to say no data could be found for your request. The same thing happens if you pick a symbol that does not exist. So no data could be found for your request. And then we're saying there is an error if candles is empty. Even if our API said, yeah, here's your data, it's empty, which it actually doesn't, but we're going to say, yeah, candles is empty. It means there's an error. So let's go back into that, how I've made it with those default values. So when we get our candles payload back, I've declared that these all have a default value of an empty list. And if you pick something really stupid, the API doesn't actually return you high, close, and low with an empty list. It doesn't even include them on the response. So I still want that to parse into my model because I don't really like handling that kind of parsing crash. So I've just put this as a default value. So this will pretty much parse anything into a candles payload, even if it has nothing, right? Because I have default values on everything. So I'm just handling the error in a different way. Instead of those being missing from the API and handling it there, I'm handling an error if everything is empty. And then we return candles from our load candles method here. So on API exception, which is the only exception that we actually think should normally happen, which is going to come from this line from our API, we can catch that and then admit that our state has an error. So we're no longer loading, but we do have an error, and this is the error message. So yeah, that's our flow for our block. So the user says, load me this stuff, says, yep, we're loading. We pick them a scale that works, and we try to get them their candles. And if it works, then you got candles and the state change, and if not, then we have an error. Okay, so now that we've made our app state, just as one part that I didn't really write down here, is that you need to provide that block to your app. So in main, I have a block provider here, and block provider will provide this block to everything below it in the widget tree, which is in my entire material app. And that block, again, needs the API, which we have created in main up here. Okay, so we got our state. Now let's look at our search form. So the search form allows us, again, to make that query here. Actually, I'll leave that open. Okay. So first, actually, let's look at our search page. So this is the screen. This probably could have just been one file, but it's just a scaffold with our search form in here. And if you have keyboard, it's quite important to put it in something that scrolls, because if the keyboard overlaps with something, it'll cause a widget crash if it doesn't have room to bounce around. So yeah, let's go into our search form here. Okay, so here's our search form. It is stateful. So when I'm doing things with UI that's relatively simple state, right? You pick a date and then the screen updates with that date. No other screen cares about this date. And we don't care about this date as far as the app state goes if they leave this screen and never search at all, if the app had somewhere back to go to. So I use a mix of block here and local state. So I think it's perfectly fine to use the tool for your state that matches how many widgets need to actually know about this. And in this case, only this needs to ever know about it. So I don't really need to use whole block for it. I think I can just put it right here. So what we have is a form key. So I'm using the form widget, and that needs a global key for its validation. This is the previous request so that I can populate the data. So if we go search and we go backwards again, it has all of this data pre-populated in. And then this is the start date, end date, and the symbol controller. So the text editing controller for this field right here. So we're setting up these with initial values of what the user last picked. So here's my form, and it's got the form key. So each field in here needs to know how to validate itself such that when the form key tries to get validated when you submit, the fields know whether or not they're valid so that the form knows whether it's valid as well. So let's first go into the symbol entry. So this is just a text field with some padding. It's got an input decoration with the symbol and the hint text. So if you don't know what that really means, you could just type in AAPL and find out what Apple has. Has the text editing controller here, and it has a validator. So it's required, and we do not allow white spaces. The symbols for stocks cannot have white spaces. Okay, so I made a mistake there. I might fix this later. This only finds spaces at the end, not spaces in the middle. So really I need to remove all the spaces and white spaces and then check the length or something like that. Or maybe do a string contains. Okay, but anyways, that's the symbol entry. Next up, we have the date select. So the date select is a custom form field because there isn't really a material date picker widget out of the box that's a form field. So it's a form field that picks a date time. And its initial value, you got to put the initial value here so that when you go backwards into the screen, the form sets up its initial validation state properly. So the validator here, start date is required, and start date must be before the end date. So if we go here and pick the 18th, we hit search, start date must be before the end date, and end date must be after the start date. So the form field widget needs a builder, and the builder has a ability to check with this field whether or not it has an error and what the error text currently is, so that you're able to put that wherever you want when you're building your widget. So first I'm figuring out the text color. If there's an error, then it's red. Otherwise, it's just the text color that it would have been without anything there, just null. And this is just a list tile. So the title is either the start date that they've selected or the string start date. So if it's empty, it's just a start date. And then the color there is currently red because we have an error. The subtitle is the error text, or if there's no error, then it just gives them instructions of plot from this day. So let's pick a valid day again. So there's what it looks like without an error, but dates are still selected. And here's an on tap to actually pick a date. So we're going to show date picker. That's a material thing built in for us to get a date. So that returns you a future date after the user has picked something. The initial date is a date that is initially circled. So I've made it for a little UX bonus here. So when you click it, the initial date circled with this blue here is the one that they currently have selected if they've ever selected something. Otherwise, it's a week ago. The first date that you're allowed to pick, if you scroll back far enough, is in 1900. And then the last date is always datetime.now because you can't really get stock quotes from the future, although that would be pretty nice if you could. So then if date is not null, then we just use set state and update the field with what has changed there. And then the trailing is just an icon that doesn't do anything. The end date field is almost identical except for it says end date everywhere. These probably could have been refactored into one method or one component, but it's a bit duplicated right now. The only weird thing about the end date is that we want to plot to the end of the end date. So we don't want, when you do a date picker, it'll pick you the time as all zeros. So it'd be like 0, 0 seconds, 0 hours, 0 whatever. We actually want it to be the end of the day. So as a bit of a, I don't know if this is that hacky or not, but I've just made it so that the date that you pick has 59 minutes, 23 hours, and 59 seconds added to it. So it still displays the date that you picked, but internally it's working like to the very end of that day. Okay, so that's our field. So when we submit it, what happens is we check that form key and we validate it. And the form fields, because they're all form fields, know how to validate themselves and display an error if there is one. So when we hit search, it's not valid because this field is not valid yet. So when we hit search when it is valid, we're going to look up our block, call that load candles method. I didn't actually use the return value here because we're just going to instantly go to the other page, which has our loading indicator. So let's open up that page next. So when we hit this with everything valid, which looks valid, we're going to see this loading indicator, and then it's going to give us some candles. Let's put this backwards a little bit more, just because I like the look of that more. No reason other than that. Okay, so looked at the form. Now let's finally look at our charting. So here's our chart page. Actually, sorry, I can't remember if this is actually used anymore. This is not used. Okay, so here's our chart page, and it is a stateful widget, and it's got a couple things in init state and dispose. So I've changed the UI based on whether or not it's portrait or landscape. In landscape mode, the app bar is kind of obnoxious. It takes up a huge amount of the screen. So what I feel like when you're looking at a chart in landscape, you just want to see the chart. You don't need the app bar. And then we go vertical again. iOS users will get that back button. Android users, being superior, could obviously always go back. But iOS, they aren't responsible enough for a back button that is native. So here is our app bar title. This just comes from the recent query. So it's the symbol and then the resolution string here, the label. In init state, I have made it immersive. So what this does is it hides the time of day and like the system UI up here. So when you go landscape, the date and stuff do not overlap with the numbers on the chart or anything on the chart. And then when they go back, I'm setting it back to where they were. So system chrome.ui mode has to do with which native things are appearing. So you can see on the screen, I actually don't have like the time, but if I go back, I have it here. So that's how I did that there, and it takes a second to disappear. I think that this makes a big difference in landscape, because in landscape, it's a bit weird. Whenever something's going across the entire top, which when it's rotated, is taking up a lot of space, so I like to hide stuff. Okay, so this screen has a block builder, so that we're building it based on our app state. So we're making the assumption that if you got to this screen that there has been a query made. This doesn't mean it succeeded or not, though. So it's all in a scaffold. It's a screen. When you're in portrait mode, I'm giving you the app bar with the back button. And in landscape, I'm not giving you an app bar whatsoever, so it hides that there so we get more real estate. So in the body, first I'm checking if it's loading. If it's loading, I give that loading indicator widget. So let's just take a look at that widget because I think it's pretty cool. So here it is bouncing around. So the background color is just matching with the current background color of my scaffold. And this is a loading indicator. So here's another plugin that I've been using lately. It's got a whole bunch of loading indicators, obviously, that have been really, really pretty and really easy to use. So this one is called Audio Equalizer. If we go to their plugin here, loading indicator 3.0.2, they got an awful bunch of loading indicators, and they're just widgets you plop in your code and you get, look at this Pac-Man. That's sick. Imagine how long that would take you to make. Love this plugin. So that's how I'm making this stockish kind of bouncing around loading indicator, just with that plugin, and the colors are red and green. So let's change that back to how it was. So then if it failed to load, that's when you saw that message when I searched for a stock that doesn't exist. So your search failed with the following message, and it's the state.error. Otherwise, we know we have some candles. Excuse me. So when we have candles, we're going to get a chart. And here we're using that chart class SF Cartesian chart. Put a little bit of padding around the outside, especially good when there's no app bar. So the primary x-axis, I have made it a category axis. So there's something a bit weird here. When you're plotting stocks, let's open up Webull again. The weekends actually have no data. So if we go here, it actually jumps dates. So let's find one. So it goes from the 10th to the 13th because the stock market isn't open on the weekend. But on stock charts, you don't expect to see two blank spaces there. You expect it to be continuous, and just everybody knows at weekends nothing happens, right? If you make this a date time axis, what happens is it actually has empty spaces. So I've made it a category axis, and I've made it such that I am mapping each candle's date to a string and then grouping them by that. And since none of them have the same date, then it still works out. And this is how I'm hiding the empty spaces where you don't have any data on the weekend. So category axis has a huge amount of stuff that you can change. Like most things with this plugin, it's actually, you could do a whole course in this plugin with how many different things you can modify. I'm really only scratching the surface here. Super good plugin. So here's the primary y-axis. This is a numeric axis. So this is the stock value. And I have made it so that the minimum is calculated. So the minimum is a little bit below the lowest point, and the maximum is a little bit above the maximum point. I'll show you how some helper methods on candles that I've made in a second. Interval is the number of lines that you get. So it's important to set the interval, because if you plot it over a huge amount of time, or it's a very volatile stock, it's going to go up and down a whole lot, but we only have room for so many lines. And it also depends a bit on whether it's portrait or not. So we go back to Apple and look at the yearly chart, or monthly chart, sorry. See that I still have like the same number of lines, the interval is the same, but they just jump a bigger value. So that's how you would control that. If I don't do this, it's going to try to put a bajillion horizontal lines. So we still want them to be relatively kind of square here. And then the series is the actual data that it gets. So a chart series is their class, and then it takes two generic types. It takes the type that it's plotting basically, and then the x-axis. So let's look at my candle helper here. So this is a utils. So this is an extension on list of candle. This is a pretty cool thing that Dart allows you to do. You can put extensions on things with a specific generic type. So when I have a list of candles, there's a whole bunch of stuff that I can do with them. First off, this is the percentage padding that I want on the top and the bottom. So this is the maximum value of any candle. So we know the max is the high of the day. And this is method fold. Since we're in a list class, we have access to it directly. Fold, and the initial value is double the negative infinity, and then we're just checking and trying to find the absolute highest high. And then minimum is similar, we're trying to find the lowest low. So fold basically takes your list and puts it into a single value, so it's a really good way to find max and min. I think this might already exist for in other packages for working with numbers, but I put this on my candles as well. So the minimum plot value is just minimum times 1 minus the percent, and the maximum is the same but plus the percent. Rounding to double is important so that the numbers are all whole numbers and it doesn't write a bunch of decimals on your plot. Okay, so here's part of the meat of it. This is the candle series. This is what the plot actually expects to be fed to plot something. So here's my first class. This is a candle, and then the other generic type is a string. So we need to give it a whole bunch of mapping functions. Candle series knows everything about drawing a candle. Let's get a better zoom in so that we can look at it again. How about that? That looks pretty good. So the candle series knows how to draw a candle, and it needs the exact info that we've already mapped on our candle class, which is that the high, the low, the open, the close, and then it needs two colors, the bear color, which is when it went down, and the bull color, which is when it went up. And it figures out which color to use based on whether the open and close, so we don't need to do anything logic like that. So the X value mapper, the X value is again the timestamp, but I've made it into a string. Again, the reason I made it into a string is so that I don't have empty gaps when I'm using a date time axis. The data source is just this, because this is a list of candles. And then we need to define more functions. So it needs to know how to get the open out of the class candle. So it's just c.open. Similarly for the high, it's just candle.high, candle.close.low. Once you've mapped out your data in this way, if it already matches a candle, it's pretty easy to use this candle series. Obviously, it's not a whole lot of work here. It's almost mapping like one-to-one. The logic to get the interval is pretty simple as well. So I've just arbitrarily decided that the interval for landscape is 16 lines. So when I'm in portrait, oh, this should be called portrait interval, sorry. So when we're in portrait, we want 16 lines, and when we're in landscape, we have half as much room, so we only want half of that. So we get the plot height, which is max minus min, and we have access to those up here. And that is the height in like Y raw values. So this height of this one is about like 116 to 182. So we just figure out how many, we get the plot height divided by the lines to get the interval of how many that we need. And then round to double is used just to, again, to make it whole numbers, because it expects when things have decimals, it will write a decimal out on the chart, which is not really desired for me right now. Okay, so let's look at the chart page again. So because we've imported those extensions up at the top, our candle helper here. When we have a list of candles, we have access to those methods, right? So minimum plot value, maximum plot value, the interval, and then just put that series right in there. Okay, well, I hope you enjoyed this tutorial on stock API and charting. I will commit these changes that I made as I found doing the tutorial, and you can look at the code on GitHub, which will be in the description.